What's up, guys? Today we're going to convert numbers from standard form to scientific notation, and then we're also going to convert numbers from scientific notation to standard form. Here it is. So here we have a number that is written in scientific notation. And for something to be considered scientific notation, we need a single non-zero digit to the left of the decimal. So here we see a 7, so that is one single digit that is not 0. And then we have a decimal, then we have some other digits, maybe we don't have digits, we could have a 0 here possibly. But then we also need to be multiplying whatever this number is by a power of 10. So that's what scientific notation is defined as. And when we're asked to convert scientific notation to standard form, basically we're just asked to write the number that this thing would equal if you were to type it into a calculator, for example. But thankfully, we don't need a calculator to do this because of the properties of multiplying by 10. So for example, if I were to take this 7.21 and just multiply it by 10, well then all I would have to do is take this decimal and move it to the right once. So 7.21 times 10 would be 72.1. So here the only difference is I'm not just multiplying by 10 once. This exponent here attached to the 10 is telling us that we're multiplying this number by 10 twice. And so we're not just going to move the decimal over once, but we're going to move it a second time. And so this is going to equal 721. And so this is the standard form, right? Just plain old 721. And this is that number expressed in scientific notation. And it's important to remember, it's a small detail, but it's an important one, that these two numbers are equal. So if you type them both into a calculator, you get the same thing. All right, so let's try another one here. So here I have 3.2 times 10 to the 4th. And again, this is scientific notation because I have a single non-zero digit here, that's 3. And then a decimal and a digit afterwards. Maybe, again, you don't have to have a digit after, but usually there is. And then we're multiplying that by some power of 10. And so this times 10 to the 4th is telling us that we're multiplying this number by 10 4 times. And so we're going to take this decimal and we're actually going to move it over 4 times. So 1, 2, 3, 4. So now notice how we have some empty spaces here, and so we're just going to go ahead and fill them in with zeros. And so this number equals 32,000 in standard form. Now here, this one's a little bit different for 2 reasons. One, this is the first example where we actually don't even see a decimal. And 2, the exponent in the power of 10 is actually negative. And so the first thing you want to do is identify where your decimal is, right? So 5 is the same thing as 5.0, right? And so by default, your decimal is going after the 5 here, okay? And now when we multiply a power of 10 with a negative exponent, that's the same as dividing by 10 over and over and over again. And so when we see this negative 3, that tells us that we're dividing by 10 3 times. And so instead of moving my decimal to the right 3 times like I normally would, I'm going to move my decimal to the left 3 times. So there's my new decimal, and again, when I have these empty spaces, I'm going to fill them in with zeros. And so in standard form, this would equal 0.005. Okay, we'll do one more. So here I have 2.435 times 10 to the negative fourth. This means I'm going to be dividing by 10 4 times. And so I'm going to take my decimal and move it left 4. 1, 2, 3, 4. And then I'll go ahead and fill in zeros into my empty spaces. And so this is going to equal 0.000245 in standard form. All right, so now what happens when we have numbers that are in standard form and we want to write them in scientific notation? So it's important to remember what scientific notation is, right? It's a single non-zero digit followed by a decimal multiplied by some power of 10. All right, and so your first job here is to find your first non-zero digit. So I'm going to go left to right, and then as soon as I see a non-zero digit, which turns out to be my first digit here, it's a 5, I'm going to write a 5 followed by my decimal. And now I'm going to fill in the rest of the digits. Okay? And now we have to figure out what power of 10 to multiply this by. So what we've done here is we've sort of artificially placed the decimal here, right? But it's meant to be there. And so all you have to do is think about, well, how do I get the decimal from where I put it to where it's supposed to be? Well, I would have to move it to the right twice, right? And how do we move the decimal to the right twice? Well, we'd have to multiply by 10 2 times. And so we're going to multiply this number by 10 to the power of 2. And then there's our scientific notation. Okay, so here we have 4,021. And so again, your first job is to find your first non-zero digit. And again, that turns out to be the first digit that we see, that's 4. And so I'll put my decimal after that, and then I'll fill in the rest of the digits. And so again, we've artificially placed a decimal here. Right, we've put the decimal here, but we know it really belongs at the end of the number. Right, and so how do we get this decimal to where it's supposed to be at the end? Well, we'd have to move 1, 2, 3 to the right. And so the way we move the decimal 3 times to the right is by multiplying by 10 to the third. Okay, we've got a couple more. So here we have 0.2003. And so again, from left to right, I'm going to find my first non-zero digit. So in that case, it's going to be 2. Then I'll place my decimal, and then I'll write in the rest of the digits here. All right. And so here, we've artificially placed the decimal after the 2. But as we can see, the decimal's really supposed to be before the 2. And so how do we get that decimal from where we put it to where it's supposed to go? Well, that's going to the left once. So we need to divide by 10, or in other words, we need to multiply by 10 to the negative first power. Then finally we'll end with 0.007 here. First thing I'll do is find my first non-zero digit. In that case, it is 7. Then I'll place my decimal. And then I'm going to write all the digits after the 7, but there are none. So I can just leave it as 7.0, or you could have just left it as 7. Doesn't matter. And then we need to realize that we've artificially placed the decimal after the 7, but we need it to be over here. And then so to get it from there to there, we need to divide by 10, right? We need to go to the left, not once, not twice, because that'll give us that first 0 there, but 3 times, because then we would have 2 zeros to fill in the spaces, which is what we need. And so there's the new decimal, and we could fill in the spaces with our 2 zeros. And so here we're going to divide by 10 1, 2, 3 times. So in other words, we're multiplying by 10 to the negative 3rd power. All right, guys, and that's been demonstrated.